We saw in the last video that one way of using strings in C++ is to use C strings, C-style strings. C-style strings are just arrays, same thing. But here's the thing, we definitely need null termination characters somewhere in these. For example, in this case, somewhere in these 5 locations you need a null termination character. It can be right at the location 0. The very first location can be a null termination character, which means you have an empty string. Or you can have some characters, and then somewhere before the very last, or somewhere in this array, you need a /0, a null termination character. Okay, so with C-style strings, we can go in there and change different locations of this array. So for example, let's say we have a 7 location string. I'm sorry, 7 array location array of characters, which we initialize to have these 6 characters plus the null termination character at the 7th or location 6. And if so you can do stuff like this, right? You can say that the 6th location, which by default will have the null termination character, we're going to override that with, and these should be single quotes, this won't work with double quotes. We can override that with something, but then once you do that, the null termination character will be overwritten by a Z character, and you can get all kinds of problems. That is, without the null termination character, anything that tries to check for null termination will fail, and therefore you might go out of bounds, and then you can get, basically you can expect unpredictable results. It might work, might not work. So the same program, compile once, might sometimes work and sometimes not work. Okay, let's just take a quick look at that. So here we set up a character array with the null termination. Of course, if we don't have that, remember we saw this the last time, save it, compile it, and run, and we get all this extraneous stuff. So it went beyond the bounds of the array. So let's just do another example of this kind of thing. So let's say we have 5 locations, and we say that we initialize this to a string literal constant ABC. This will always work. Okay, compile it, run it. This will always print ABC, no problems. So you can run it any number of times and it'll always give you this output. But what we can do is we can say S sub. Here's location 0, 1, 2, and so in location 3, we're going to put in, overwrite the null termination with, and you have to use single quotes here. Double quotes, I believe, will give you an error, so let's try that. Double quotes, I think there was a typo in my lecture notes. Yep, so double quotes definitely do not work. You have to use single quotes. Typo in the book, or typo in the notes. Alright, let's run this, see what happens. Not much. So in this case, I think we were just lucky. So let's say we do this, A, B, C, D, E, F, G, H, I, J, K. And so that would be location 0, that's location 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And let me see that we have to count again. That's location 0 is A, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 is K, so 11, This is where the null termination should be. Let's comment this out first, make sure the baseline code works. It should print out those 10 things. So, not enough room. Let's just not have that. That works. Let's run it. This should work. It should print out that. Now we're going to blow away the null termination character. See what happens in this case. The last time we tried to do this with a short string, everything sort of worked. In this case, you can see it didn't work. So you can't really predict when it'll work and when it won't work. In this case, it sort of didn't work. You get all this extraneous stuff. And maybe we just happen to have a null termination character here, just lucked out. So it's possible, sometimes it'll work, sometimes it won't work. Okay, move on to the thing that we really should use, which is, well, actually not right now, but you should use the new C++ standard library strings. But there's also a library for C strings. It does not require the more complicated C++ library. This is available in standard C++. It's just really just part of the C specification. And if you want to use all of the library functions for regular C-style strings, you have to pound include this C string. Not able to click on here. So if you pound include C string, there's a whole bunch of functions that we can use that manipulate C-style strings. So for example, C strings are not like other variables. You cannot, for example, assign or compare. So for example, if you say car A string with 10 locations, unless you are assigning a value right at the declaration, if you don't assign something at declaration, or if you do assign to, later on assigning some other string to it is illegal. You cannot do that. You can only use the assignment operator when you declare a string, that is C-style strings. Other times you have to use a library function. So the standard one that you can use is strcpy. The thing to watch out for when you use strcpy by itself is that what this will do is it will copy. This is like saying a string, and this is the way you want to think about the order. This is like saying a string equals the second argument to this strcpy. So what it'll do is it'll do a character by character copy from H. It'll take H, put that into location 0 of a string, take the E, put that in location 1, and so on. Eventually, as you know, there'll be a null termination character at location 5, I believe. 0, 1, 2, 3, 4, 5. Yep, 5 at location 5. There'll be a null termination character. It'll be copied to this A string, and that will stop the loop in strcpy. So where is this from? This is a built-in function that comes from this C string library, this library of C-style string functions. And the thing to keep in mind is that there are no checks for size. So what does that mean? That means that, let's say you assign a 10 character array, 10 character string, which means basically, I guess let's think of it as an 11 character array into this A string. You have to guarantee that A string has enough memory to hold all of those characters. So in this case, if you could declare A string to be of size 5, and technically it should not work, but it'll allow you to do it. So let's take a quick look at an example. So let me just switch this around. Let's say this is an 5-character array, and I'm going to put in HELLO. We know that this should not work. This compiler will say that there's an error because there's 1, 2, 3, 4, 5 characters plus the null termination, which is 6. So this should be 6 for this to work. Right, so we got the error message. Alright, so we know that this should be 6. So now what we're going to do is we'll try to do the same thing, but here we'll say S is equal to HELLO. And we just saw in the notes that this is not allowed. Let's see what happens if we try to do it. So it should give us an error message. Yeah, cannot do that. Alright, instead what we have to do is use a C-style string library function called cstring. This is not the C++ string class. This is different. This is just a library of functions for C-style strings. Okay, so this is like saying S is equal to hello, but what it does is a character by character copy. So technically this should not work because we only have enough locations for 5 characters, but remember there's a null termination. We'll try to copy that, and what will happen is you will see that I think C++ will let you do this, I think. Yep. So no compilation errors. You should have gotten one, but there's no way for the C++ compiler to check all of these things. And let's see what happens if you run this. It works. So should not work, but it works. Why should it not work? Because we don't have enough locations in S. So you can say 2 here. Oops, not 52, but 2. And we know this is not enough memory to hold this string, but there's no errors from the compiler, and there's nothing wrong when you run it either, but we are actually going out of bounds. So this strcpy is actually going out of bounds. It is up to the programmer to guarantee that there's enough memory to copy all of this stuff. So right now, what we're doing things wrong. We're just checking to see if we can do it. What this is doing is it's copying a lot more characters than you have memory for, and so it's probably overriding something. We don't know what. So this might be the results of this. Probably, it might work, but some things might fail too. It's unpredictable. Okay, so assignment is not possible with C-style strings. The only time you can use assignment is at the declaration. So when you declare a C string, like right over here, if you said equals hello, that would be fine, but if you put a semicolon and then very next line you try to assign the same thing, it's illegal. Okay, so only when declaring. And there's a whole bunch of these functions. We'll go through a few of them. We can use string copy to do what we tried to do here but couldn't. That is, assign this string hello to this string, and we as the programmer have to guarantee that there's enough memory. Okay, so in that way it's just like any other array. We can go out of bounds in C++, and the compiler won't stop us. It's only in when you run certain programs, if you go like far enough, way beyond, let's say you have a 2-character array and you go to the 100th location, yeah, you might run into problems, your program will crash. So those are things you want to avoid. Also, you cannot use the equality operator. That is, you cannot do this and expect it to do anything rational. Okay, what you have to use is the string compare. This just compares character by character, checks if each character, like location 0 versus location 0 of this string, if they're the same, keep going. If it's different, it stops and it returns, basically I think it'll return an